Hi, Noel Chemists. It's Miss Rose. We're going to start talking today about the periodic table in preparation for you to take your next focus area on the periodic table. If you haven't taken the focus area on atomic structure, not to worry. Now is the time to begin studying and to take that focus area. Please take that focus area first. Okay. I'm going to share my screen, and I have linked let me see here if we can find it. I have linked this particular slide deck in this focus area. I'm sorry, in this checkpoint. So I have linked this slide deck in this checkpoint, and I'm going to review this slide deck with you right now, and I urge you to review it yourself independently before taking the focus area. Okay. So let's take a look at the periodic table. First of all, the periodic table is organized in this method. We talked about Dmitry Mendeleev, who was the person who began to organize the periodic table in this way, lining up groups of elements that had similar chemical and physical properties and leaving spaces for those that he knew would fit in there but had not been discovered at the time. So, this very first group is called alkali metals, except for this very top one, which is hydrogen. The next group is alkali earth metals. The next group is transition metals, several bank of elements here. Then we have a stair step. Underneath the stair step are other metals. Sort of in the stair step are something we call metalloids that have some of the properties of metals and some of the properties of nonmetals. And then we have this group of nonmetals here. The last group before are noble gases, which is truly the last group, but the last group before them is called halogens, and these are things like chlorine, bromine, these kinds of things. And then we have these noble gases, of which helium and argon are some. Underneath here, we have rare earth metals. So if we quickly look at this periodic table, we see that most of the elements are metals, and a few of the elements are nonmetals. And here's another periodic table, and this one actually has the elements listed, and so that we can see this first column was alkali metals. The second column was alkali earth metals. And then this wide swath of transition metals. And then these metals that are underneath here, the stair step. Here is the small group of 6 that are metalloids that have both characteristics of metals and nonmetals. And then we see here the nonmetals. Here, the lanthanide and actinide series are pulled out and placed down below, and these are the rare earth metals. Okay. So you might see a question like this that says the symbols W, X, Y, and Z represent 4 elements on the outline of the periodic table, which is classified as a metal. Well, we know that above the stair step is not. So this is not a metal. This is not a metal, it's actually a noble gas. These over here have both metal and non-metal characteristics. Underneath the stairwell are typically metals, but very close. Here are Z, we know, is clearly a metal. Okay, so first question, the majority of the elements found in the periodic table of the elements are nonmetals, gases, metals, or liquids. And we know from quickly looking that the answer is metals. Okay, because we can look back at that periodic table And we see that the pink is metals, and we are mostly pink. Okay. Next question. Which set of elements contains only metals? So we begin to look at them. Iodine, iron, nickel. Iodine. Well, iodine symbol is I, and here it is over here. It's one of our halogens. It is a nonmetal. Phosphorus, nitrogen, oxygen. Phosphorus is P, nitrogen is N, oxygen is O, and all of these are nonmetals. Sodium, chromium, copper. Sodium symbol is Na, and here it is. It is an alkali metal. Chromium is Cr. Here it's a transition metal. Or copper, which is Cu, and it is also a transition metal. So we have our answer. Sodium, chromium, copper. But let's just take a look at our last choice. Helium, carbon, gold. Here's helium. It's a nonmetal. It's a noble gas. Here's copper. It's also carbon. I'm sorry. It's also a nonmetal. Gold is actually a metal. Okay. There's our answer. All of these are metals except, well, we would need to go back to the periodic table. We know that gold is a metal. We know that sodium is an alkali metal. We know that aluminum is a metal. But helium is actually one of our noble gases. Okay? Copper, silver, and nickel are all classified as transition metals. We would go back to our chart, locate them in that group of transition metals, and there we would find them. Reading from left to right, elements in the same period increase in atomic number. Okay? Period goes this way. A family or group goes up and down. Which of the following lists elements from lowest to highest atomic mass? Well, there we would have to look at the periodic table, look at the atomic masses, and see that they're increasing. Remember, atomic mass is that bigger number. Okay. The order of the elements in the periodic table is determined by the number of protons as we go across the periodic table from 3 to 4 to 5 to 6 to 7. That's an additional proton in the nucleus. Okay. What do the atoms in this family of elements have in common? Well, every atom that is in a column, okay, is in what we call a family or a group. And these elements behave the same way physically and chemically. And that's because they have the same number of valence electrons. And that's the number of electrons in the outermost ring. You know, the first ring can hold 2, and then every ring after can hold 8. And the outermost ring, however many that has, whether it's 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8, that number is always the same in families, and families are up and down. So let's take a look at what some of those numbers are. Notice we've left out the transition metals here. We don't give them a number. But here, everything in this column has 1 electron in its outermost ring. In this column, it has 2. These we skip because their numbers can be variable, but not these numbers. Next row, 3, 4. Every single element up and down in this column, in this group, in this family, behaves the same. And the reason is because they have the same number of electrons in their outermost ring. 5, 6, 7, 8. Now we notice here that helium just has 2, but it only has 1 ring, so that ring is full. So the outermost ring of helium, which is just the first ring, is full. 2 is all that ring can hold, and it's full. But every other ring can hold 8, and so we notice that every other element in that family has 8, which means the outermost ring is full. The outermost ring is full here in all of these, okay? And so here's another look at it. 1, all of these in this group or family have 1 electron in the outer ring. This is 2. We skip over these transition metals because they can have varying numbers in the outer ring. And then we go to 3, 4, 5, 6, 7, 8. But we notice helium is special here. Helium only has 2. Everybody else has 8. In an atom, the electrons located blank are available for bonding. Well, it's that outermost shell. And that is the reason why every one of the elements that is in the same family behaves the same way chemically and physically, because they have the same number of electrons in the outermost shell, and those are the electrons available for bonding. And so here we see it again. It says nitrogen has 5 valence electrons. So we see the 1, 2, we skip over all the transition, 3, 4, 5. Nitrogen just have 5. Based on this, what other element would behave like nitrogen? Well, anything that's in that column or the same family of nitrogen will have the same number of electrons in their outermost ring, and it will behave chemically and physically exactly the same way as nitrogen. And that element is not neon. Neon's way over here, Ne. It's not carbon. They're not in the same family or column. It's not oxygen, but it is indeed phosphorus, the element P, phosphorus, right below nitrogen. They're in the same family, which means that they have very similar chemical and physical characteristics. And that is because they have the same number of electrons in that outermost ring, and that is 5. Okay. The number of valence electrons in an element affects the reactivity. Which element listed has the fewest valence electrons? Well, we need to go back and look at what these elements were. But let's go back. Beryllium, sodium, oxygen, neon. So now let's go forward. Beryllium is Be, so it has 2. Oxygen is O, so it has 6. Let's see what the other ones were. Now they already escaped me. Beryllium, sodium, oxygen, neon. Okay. So beryllium is Be, it has 2. Oxygen has 6. Carbon has 4. Helium has 8. But look at here. Sodium, Na, has 1. So sodium has the lowest number of valence electrons. Okay. Which element has 2 electrons in the outermost level? Cesium, magnesium, boron, argon. Okay, so we got the chart. Cesium, Cs, 1. Magnesium, 2. Oh, there's our answer, but let's just check. Here's boron, 3, and argon, which is Ar, is 8. So our answer for which one of these elements has 2 in its outermost ring, it would be magnesium. Okay. Now the periodic table, the elements are arranged also in these trends. And I'm going to talk a little bit about them, and there will be some questions on your assessment on these trends. So first and foremost, I want to talk about electronegativity, which is in the purple here. Electronegativity means the ability to hang on to electrons. Those electrons, just pull them in close to the nucleus. Remember, the nucleus is very dense and positive, and electrons buzzing around it are negative. And so that pull into the nucleus keeps them. And so we're going to go through and take a look. as you go across a row, 1 and 2 and 3 and 4, the electronegativity increases. So therefore, electrons are pulled into that nucleus more. And that's because we're adding a proton in the nucleus each time we go across, and then the nucleus is becoming more positive. It's also more positive as we go up. And that may seem a little bit counterintuitive, because as we go across, we keep adding protons so that this nucleus is becoming more positive. It would seem to pull the electrons in more. But what actually happens is, as you go down and you get bigger, you're adding more rows of electron cloud. So the distance between the electrons in the outermost ring and that positive nucleus starts to get bigger and bigger, and some of these electrons create what we call an electron shield, or they block that attraction from the positive nucleus to the far out electrons by being in the way. So we see that the most electronegative element is fluorine, or F. And so if you ever see a question about that, it's unquestionably fluorine. Fluorine comes at the end. It is the most electronegative. So the trend is, as we go up from the bottom up, we get more electronegative. And as we go across, we get more electronegative. Atomic radius is another question they may ask you about, and that's the size of the atom. How big is the atom? And what happens is, as we go down the chart and we start adding more protons and more electrons, we get very, very, very big. So you can imagine that as we go down and as we go across, this atomic radius gets very, very big. But again, some of the reason that the atomic radius gets bigger is that we're adding these shells of electrons out and out and out and out. So that's part of what we're finding. So if you look at this chart, if there are any questions about trends in the periodic table, you can return to this chart and it will help you, okay? So I'm going to stop here for right now and say that the next part, in the next video, we're going to be looking at a scavenger hunt that will also prepare you for this particular focus area. Good luck. As always, reach out to me if you need any help.